How's it going, everyone? Welcome, Julian Gonzalez here. And today, let's continue to look at this book, the chapter one, talking about and discussing, exploring about the closures, and especially scope and closures. So that was a very intense chapter, by the way. It was very dense in terms of the describing that variable is the most common important topic in any programming language. It was the most fundamentals. So working with variables is one of the most fundamental things in things we do in programming, and we may have considered very closely the underlying mechanisms of how that things work, especially in the engines. So understand that how JavaScript resolve it is named with a value. Another is that how JavaScript how JavaScript handles when two variable has the same name, and how variables or how JavaScript engines figuring out what variables can be access, or what variable you can have access in a given statement. Okay, so it's looking at this reference to answer these two questions, and the answer to these questions is takes in the forms of a well-defined rule called scope. So this book will dig through all this scope and how it works and what is useful, gotchas to avoid, and then point toward common scope patterns that guide the structure of a program. So we went through that. So how it works, how now this scope, this well-defined rules works, and what is useful, and some gotchas to avoid using, for example, for example, the eval in that case. So, yeah. So how this work? How this work? Okay, how this work? Okay, how the scope, how this set of well-defined rules works. Okay, when it comes to identify at a given statement if that variables to the to the tag at a given statement, if that variables so we if we can have access to that variable to determine at a given level if I can have access to that value, and also is how now the JavaScript engines uh, handles this handles when two variables name are the same, right? And we're gonna see how that works, what is useful, and gotchas to avoid, and then point toward common scope patterns that guide the structure of a program. Scope patterns, scope patterns that guide our programs. Scope patterns. Scope patterns. Okay, that guide our programs. So about this book, welcome to the book 2 in the You Don't Know GS Jet series. If you're already finished, get started, the first book, you're in the right spot. If you're not, before you proceed, I'd encourage you to start there for the best foundation, which is something that I already did. And in this get started, I really love about that huge overview. First, by I'm not gonna repeat myself, just gonna go over very quickly. Uh, with first we say what is JavaScript. So who made that? Where does the name come from? Who oversees the technical spec? who owns now the legal trademark, and what this group that oversees the spec uh, actually does, what is the goal of that group, what is the phase of in which these groups propose and finally work its way up to the top until that is accepted in the spec, and how now, despite the best effort of that commit, the TC39, the reality of the web sometimes is quite different, and therefore they have some drama cases like the Mushgate. Uh, and even though that, despite that you can now have all of these JavaScript engines that can run in different environments, whether it's on the browser, on the server, on the libel, or robot, the only reality that matters is the web, which is what the spec is focused on. Because the web is so diverse, well, there are some particular spec on the on that spec in the appendix B that describe that for some legacy reasons and other reasons as well, uh, some behaviors in the JavaScript engines are not contemplated, all right, or they go in their own way. But in any case, we also look at what the JavaScript console in browser is not a strict ECMAScript spec compliant. In despite this, in because the mode of the TC39 group is to don't break the web, why we use now polyfills in order to satisfy that and to provide this backward compatibility unlike any other programming language. Okay, and also the idea or the different approach that we can use in JavaScript, whether it's procedural, functional, as well as object-oriented programming, and how now the language works, briefly speaking, by in essence, if not in practice, be a compile language, right? Because the way how now the language handles errors, right? So it has this parsing phase, and how now, despite that the JavaScript concerns in terms of parsing and execution of the code, in terms of speed of the parsing and execution of the code, there was some attempts to successful attempts to understand that if JavaScript is fast enough, which is now was able to pour a group of Mozilla developers and engineers pour a Unreal game into now the web, the browser, using now an ASM.js, a subset of JavaScript that provides some hints to the engines to do optimizations. So years by, the spiritual successor known as the WebAssembly now take things a little bit further and say, hey, let's going to remove the parsing phase by creating this intermediary representation of the language that looks like an assembly, and we can now pour is multiple programs in different language into this or compile different programs in different language, and then we can run that in these environments, these WASP environments. So I do find that that is quite interesting and revealing, because that lead us is to the understanding that JavaScript in itself can be, it is fast, and because there are now some legacy features that we must avoid in order to have the good in order to let the JavaScript engine to have a good chance for optimizing and running our code, this is why we look at the strict mode. So, which is just a set of rules that developer must go with to have a good chance so we can tell the JavaScript engines to have a good chance of optimizing and running our code. So there are also some things that we can dive deep into the strict mode and why the semantics change and why, for example, the JavaScript console on the browser is not a spec compliant because it doesn't behave as it is. By looking now at the strict mode, this is one of the case, among other features as well. So, but in any case, this is just what chapter 1. And in chapter 2, we say, hey, let's gonna survey our knowledge in JavaScript. So to understand what is a program, how JavaScript see a programs, especially these single standalone programs, and then what a value is in a program, which is the most important unit of information that allowed to represent is the state in the programs, so we can manage it. So these values are handled by the programs. So these values now manage the program. Okay, so these values manage the inner state of the programs. So values like string and number that actually follow a particular spec. So for example, Unicode, which is an encoding character, where you have now this binary representation that maps to a particular character, and how previously we have the ASCII character as a way to represent only the Western characters, all right, Latin and English, particularly the English. But as the web now becomes widely adopted and similar as computers that can be used in any culture, so the programmers look at that and create now this particularly encoding character by looking is at the challenge that they have. So they look at the challenge that they have, the challenge that they were about to get, and therefore they create now this solution. This is for the string and how we manage that, and how the strings looks like. Again, this is go beyond the scope of today's video, but I do find that strings in itself is very interesting when it comes to describe that, right? That sequence of characters and how that sequence represents. So part of them is basic multilingual characters, which is a range, like a table, all right, from 0 to 65,535, that represents all of these different possible character in the human, and then we have also is the abstract plane, which is now those that are beyond that length. This is when we have now emojis, for examples, and then we look at the string number, that is this sequence of characters that allows to represent is up to a finite numbers due to the limitations that we have in our memory. And because of this, now we have particular issues with 0.1 plus 0.2, because they are not way to accurately represent those numbers. In other words, similar like you can represent is 1 divided by 3 in decimal, because you have now this 0.3, you know, so it is no finite way to represent that number. Similar for the number pi, okay, when it's going to give you now as you continue to compute that, it's going to continue to throw you numbers, right? And our memory is limited, so This is the reason why we actually put these things here, this constraint here. And we have now these particular issues with that, and how now the JavaScript engine actually solve those particular issues, or we as programmers solve those particular issues in an alternative that the language provide with big int, right? We also look at the booleans, the symbols that are values that are obfuscated to even developers and users, which is heavily used in libraries and low-level applications. And also it's a kind of emptiness, like undefined and null, right? And also it is nuance and the objects. Again, I'm gonna make a quick recap here, okay? And what an object is, and what are the different type of objects, whether it's an array, and functions, and even functions that are values, and how can we use those values in the language? How can we represent that via literal or via variable? And the other is that because variables in its syntax forms allow us to hold values inside of it as a containers, this represent is now how widespread we can have access to this container. So because it follows several syntax form, var, let, and const, with each one of them more constrained, or with it is constrained, okay? We also look at another place where we can define variables like functions definitions, all right? And inside of the parameters of a function, okay? And how we have now a variable in the try catch as well on the error, right? So, and also by looking at the way of how now functions plays a role in JavaScript, whether it's a procedure or a strict mathematical definitions, and understand that we can use values, functions as values. This is quite powerful because it unlocks now the functional programming that we see, and especially in React applications, which has been so powerful, especially when your problem is about computation and calculation. We have now all of these particular patterns that we can go with that makes the code a little bit more readable. We can get rid of an entire classes of bugs and provide now a systematic way to compute that, right? So we also look at the comparison and the equality, okay? With this comparison and inequality is the way of how the language makes some abstract operations, in other words, these operations without your consent, when it comes to compare two values, or coerce one value to another, to convert that to one another, and what are the algorithm that is doing, and what this algorithm is being used in the language. So this is great for understanding that, and when it comes to know what a comparison means, or what comparison mean, it is based on the referential equality. So I also look at the way of how can we organize our code here, whether it is a class or as a function or as a EX6 models. And on the chapter 3, we did dive into the roots of this mechanism that happens virtually in every line of code that we write. So we can understand now the fields, how the field of JavaScript, it is ebbs and it is flow. So for example, the iterations. So because now most of the time when we build when we design a program, they are when we any so most of the time when we build a program is to process data and then make decisions on that data. There are several patterns in the computer science that allow us to solve particular problems, right? So, for example, hey, how can we create an object? We have now the creational patterns, such as the prototype. Hey, let's going to now clone that or create a copy of these objects. The builder, the factory. So hey, let me now create is an object from this function call. Also is the singleton. Hey, let's make this object live through the entire lifespan of the application. Also we have is the structural. So how can we now is combine these two objects to act as a one? And I really love about this exploration because um, it is describing this particular problems. You know, it is describing this particular problem. It's to say, hey, how can we assemble objects and classes into larger structure? In other words, how can we now extend the functionality of our programs uh, by adding or assembling different objects into our programs while keeping this structure flexible and efficient? Mm? So we have now the adapter, which allows two objects to with incompatible interface to collaborate. This is the core of the object-oriented programming, right? The other is like bridge. So let's split a large classes or a set of closely related classes into two separate hierarchies. Uh, the abstraction and the implementation. Okay, which can be developed independently of each other. The other is the composite. Let's compose object into three structure and then work with this structure as if they were individual objects. Again, this is if you care, if the problem is how can we now assemble different objects into a larger structure while keeping flexible and efficient. So composite is one of them. So let's compose objects into a tree-like data structures. The other is decorator. So let's going to attach new behaviors to object by placing these objects inside of a special wrappers. By putting this object into a special wrappers here. The other is facade. So hey, let's going to provide now a simplified interesting. Let's going to provide now a simplified interface to a library or framework or any other complex set of classes. Flyweight. Let's fit more objects into the available amount of RAM by sharing patterns. Interesting. How much is this being used? Flywheel resembles singleton is somehow managed to reduce all the shared state of an object in just one. The singleton object can be mutatable. Fly objects are immutable. Mm-hmm. Mm-hmm. But it's a hey, let's fit more objects into the available amount of RAM by sharing common parts of a state between multiple objects instead of keeping all the data in each object. Let's fit more objects into the available amount of RAM by sharing common part of a state between multiple objects instead of keeping all the data in each object. Okay, flyweight. The other is proxy. The most common pattern here are that I'm familiar is the adapter. So let's go to create now an interface, okay, which is that. So let's go to create now an interface. Okay, let's go to create now an adapter, but in this case, uh, that allow these two objects to cooperate, and the other is a bridge. So let's split these large classes or a set of closely related classes into two separate hierarchies. So the abstractions and the implementations. I am more familiar with the composer, where you say, hey, let's go to take all of these objects and compose into a tree-like data structure. And then work with this structure if they were individual objects. The other is decorator, when you want to now wrap an object to add additional behaviors. And the other is a facade, when you want to provide a simplified interface. And the other is proxy, is that it's going to put now an object, it's going to now wrap an object that we're gonna control the access of the original object, right? So all of these are just, and again, I'm briefly describe is these particular patterns based on the problem they're solving, right? So when you have a problem that is so when you have a problem, when you have an issue related to how can I make objects to assemble into a large data structure or class while keeping flexible and efficient, right? To cooperate. So an adapter is one of them. The composite, the decorator, the facade, and the proxy here. And then we have the behavior pattern, which are more concerns about the algorithm, okay, and the assignment of responsibility between objects. Assignment of responsibility, okay. So they're more concerned about is the algorithm in itself and the interest in the algorithm in the algorithm and the assignment of responsibility. I am more quite familiar is with the observer, state. Let's use separate algorithm from the object on which they operate. So the state, the observer, and the iterator, right? Where now the iterator is why we are here, okay? Let you traverse elements of a collection without exposing its underlying representation. Lays a stack tree no matter what. And let you define a subscription mechanism to notify multiple objects about any events that happens to the object they are observing. Similar with the state, lets an object alter its behavior when its internal state change, and it appears as if the object changed its class. Chains of responsibility. Let you pass requests along a chains of handlers. Upon receiving a request, each handler decides either to process the request or pass it to the next handler in the chains. So for example, exactly like collaborating. So like collaborating, right? Chains of responsibility. It's a behavior design pattern that lets you request along a chains of handler here. And this is widely used, exactly. The request must pass a series of checks. An authentication plus authorization plus validation plus catching. An ordering system. And then you get it here. Chains of responsibility. Chains of responsibility here. And real world analogy. Oh, chains of responsibility. Chains of responsibility here. Exactly, chains of responsibility here. Okay. anyway. But again, is this? It's iterator and observer. So it's iterator and observer and the state. Okay. So, but in any case, the point is this: when you are concerned about the algorithm, about this description, this series of steps, or the responsibility assigned between objects, this is part of this design pattern, the iterator and the observer. Again, what we want to do is now is in this and this striator here. In concrete striator here. But in any case, I'm looking at this is because it's the iterator part of this low level features, or digging into the root of JavaScript, which is the iterator and iterables and iteration, right? So because the iteration is the way how can we now is go through each one of those elements into a collection, okay? Pretty much like when we go into the realm of querying data in a database, and we get this chunk of data. If the data set is way too large, all right, we get these results based on some fixed window that we define, all right. So this is a way, this particular patterns describing is how to do that and how can we consume those iterators using is the spread or the for of loop, that what it does behind the scene is to dig into if those particular objects interesting if those particular objects now can have access, if those particular objects can have access so if those particular objects can have access to the specific well-known symbol. In other words, is like a badge that say, hey, this particular object, yes, it now has implemented this protocol, this iterator protocol, and then we can now consume whatever underlying data has a reference to. And this underlying data, which is known as the iterable, okay, in JavaScript we have now is map, set, arrays, strings, and this is just to describe one particular low-level features. The other is now the most pervasive and acute to us as programmer, that is the closure. So when you define a function, is the way of how the functions remembers it is variables inside of that scope from the outside, from the outer scope, even after that function is execution in a different scope, right? So this is a way of how now the variables, or when you define is this function, and this function has reference to outer variables, it now holds a reference. It's like a kid now holding some globes, all right, and they carry over with that. So this particular analogy is that this function is, or this feature is created when you define a function, a function's definition, and then you have access to other functions from the inner function, right? So the closure in itself, we look at the different places where we can go with. Usually is in a functions, but the truth is that it can also be is when you define a function and pass that as an argument to a function call. all right, and on the for of loop. And we understand now for sure what is the var issue here. The var and the let, okay, or the cons. Also is another feature of the function, which is when you now execute your function, you have access to something called the this value, which is allow you to access the execution context, which is an object that is exposed to you, so you can now access to the variables defined in there, right? And you may wonder, hey, how can I now is have access to those variables? Okay, and how can we even now set those variables? Well, it's not the this keyword is not whatever is on the left hand side, is none of that, is that when you call this function, the way how you call this function is how this value will be determined. In other words, you can call now this function, and if the value on the left is now an object, it's going to pass down data and make it accessible via the this keyword. Or even you can now modify this shape, this value, by now calling that function, the dot call function in that moment, or the dot bind or the dot apply, right? Where you can now pass this new reference of the execution environments that you can have access to the this, right? So I do find that this is all very, very, very interesting because now when we look at another feature, which is the object prototype change, which is the mechanism in how the property access is resolved, or how the property access properties yeah, is the way how now a property access is resolved. Yeah. Well, since this is a way of to to two objects or multiple objects to cooperate in look for a lookup. Yeah, this is a way to two or multiple objects to cooperate for lookup properties. Okay. Well, if the object B from the object A, when you look up for a property is not there, it's going to delegate that to the prototype change to the object A to look up, right? And if it's not there, it's going to look up, and since yeah, and I need to chill, bro, chill. So the object prototype, which is a feature from the objects, specifically for resolution of property accessors, or resolution of property access. So if you have now two objects that are collaborating, or more, for the sake of the example is two. So if you're trying to have access to a property that is not in B, it will look up through the prototype chains to the object A if that exists. And if it's not, it's gonna now console that through the prototype change if that particular object, if that exists, now contains that property. If it's not, then it throws you an error, right? So this prototype change, that the way how can we create this link is via the object.create, okay? Where the most useful case is that let's going to define now only the functionality of these objects, all right? And then let's going to now attach that to the data when do we need it, okay? when we look at this revisited, when we revisited this keyword with the object prototype change, it makes it quite powerful when it comes to now determine, or when it comes to now extend the functionality of our programs by adding more properties to an object, all right, or by extending the functionality through the prototype change, and determine at runtime if that particular feature exists, that particular property exists. I know that might sounds very abstract, but this is the reason why we're going to dive deep into the concept later on. And this is just to describe is the Get Started book series. And I do find that it's very, very, very interesting and powerful, bro. Very, very interesting. So this is Get Started here, right? So our focus will be the first of the three pillars in JavaScript, the scope system and its function closures, as well as the power of the model design pattern. So JavaScript is typically classified and interpreted as scripting language, so it is assumed by most JavaScript programs, that JavaScript programs are processed in a single top-down pass, but JavaScript in fact parse and compile in a separate phase before execution begins. And the code author decision of where to place the variables, functions, and block with respect to each others are analyzed according to the rules of a scope. During the initial parsing and compilation phase, the resulting scope is generally unaffected by runtime conditions. But my question is that where can I get this? Okay, the co-author decision of where to place variable functions and blocks with respect to each others are analyzed according to the rules of a scope. During the initial parsing and compilation phase, the resulting scope structure is generally unaffected by runtime conditions. The resulting scope structure is generally unaffected by runtime conditions. JavaScript functions are themselves first-class values, and they can be assigned and passed around just like a number or string. But since these functions hold and access variables, they maintain their original scope no matter where in the program the functions are eventually executed. And this is called closure. Exactly. Exactly. So all of this is and this is quite interesting. I do know this, but where in the ECMAScript is telling that, about the closure, about closures. The term. The abstract closure specification is used to refer algorithms step together with a collections of values. Refers to algorithm step together with a collections of values. The abstract closure specification type is used to refer to algorithm step together with a collections of values. There is telling you. So this series of steps with a collections of values that are together. So abstract closures are meta values and are invoked using functions application style. Abstract closures are meta values and are invoked using functions applications style, such as closure argument 1 and argument 2. Meta values that describe is when a function application style like this, like abstract operations, invocations perform the algorithm step described by the abstract closure. Like abstract operations, In order to facilitate their use in multiple parts of this specification, some algorithms called abstract operations are named and written in parameterized functional form, so they may be referenced by name from within other algorithms. Abstract operations are typically referenced using a functional application style such as operation name. And some abstract abstract operations are typically referenced using a functional application style. A functional application style. So some abstract operations, okay. Some abstract operations are treated as polymorphically dispatch method of class like specification abstractions. So such methods like abstract operations are typically referred using a method application style such as some value dot operation name. If that operation is polymorphic, which means that it's going to return multiple output, they use this. Okay, let me actually clarify this. Let me actually clarify this. Based on the following text, like this. Based on the following text, it is safe to say that anytime we look at, for example, object dot method with some arguments, it refers to a polymorphic 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 abstract operation, whereas the, let's say, function, okay, let's say is, whereas, for example, multiply operation name 1 and 2, it returns a single output. It returns the same output. Not quite. You're mixing up a couple different concepts here. Based on the text you quote, when we see object method, it refers to a polymorphic abstract operation, but the syntax itself doesn't guarantee anything about the behavior or output. Okay, here's the distinction. Polymorphic abstractions operations. The same method name can behave differently depending on the type of the class. Okay. Same method named different implementations. The output depends of the object is. And regular abstract operation. These are more likely traditional functions. Given the same input, they should produce the same output. The behavior doesn't change based on the type of the first argument. So your statement multiplied by 2 return the same output is correct. Regular abstract operations are deterministic given the same input. Okay. But object method, the output depends on the value, is on the type. But the output depends of the object is. And if the object 1 and object 2 are different types, then the methods might produce completely different results. And the key insight from the spec text is that it's describing 2 different reference styles for abstract operation and not making guarantee about the behavioral consistency. Describing is reference style. Interesting. So when you look at things like this, all right, is going to depend, its behavior is going to depend on the value here, where here it should return, given the same input, the same output of this abstract operation. So like abstract operations, invocations perform the algorithm step described by the abstract closure in algorithm step that create an abstract closure. In algorithm step that create an abstract closures. Values are captured with the verb capture. Wait a single moment. Abstract closures are made of values and are invoked using function application styles such as this. Like abstract operations, invocations perform the algorithm steps described by the abstract closure. Like abstract operations, invocations perform the algorithm step described by the abstract closure. In algorithm steps that create an abstract closure, values are captured with the verb capture, followed by a list of aliases. When an abstract closure is created, it captures the value that is associated with each alias at that time. In step that specify the algorithm to be performed when an abstract closure is called. Each capture value is referred by the alias that was used to capture the value. If an abstract closure returns a completion record, the completion record must be either normal completion or throw completion. So abstract closures are created in line as part of other algorithms. Showing the example below. Let added be 41. Okay, let add n be 41. Let closure be the new abstract closure with parameter x that capture addend and perform the following step when called. Return x plus add n. And let val be the closure one. And then assert val 32, the step that begins with assert an invariation condition of an algorithm. And then assert the val is 42. But again, this abstract operation, what is telling you here, the abstract operation, what is telling you here is that on the following spec, okay, based on the following spec here, the abstract operation captures the abstract operation or the abstract closure. The abstract closures capture the algorithm with its values. Is used to refer to algorithms step together with a collection of values. With a collection of values. Attached to it. Is attaching a set of algorithms plus the capture values, which becomes an executable unit. From your example, algorithm is return the x added, and the capture is the value added with 41s, and the result is a callable unit that can be invoked later. The crucial part is the timing of capture. When the abstract closure is created in step 2, it captures the current value of added, which is 41. Even if added were to change later in the algorithm. That is interesting and makes a lot of sense. And this is now explain deeply what is now a closure here. This explains now deeply what a closure is. Okay? The abstract closure as they describe here. So because now typically JavaScript is classified an interpreted language, but the reality is that it have a parsing and compile phase that is separate from the execution. So the co-author decision of where to place variables, functions, and block with respect to each other are analyzed according to the rules of scope. So where you're going to put now block, functions, or variables in your codes are analyzed based on the rules of scope during the initial parsing and compilation phase. The resulting scope, interesting. So where you put now variables, functions definitions, or block, they are now analyzed according to the rules of a scope during the parsing and compilation phase. And the resulting scope structure is generally unaffected by runtime conditions. So since JavaScript functions are values, they can be assigned or passed around just like numbers or strings, but since these functions hold and access variables, whether it's internal values or outer values, outer variables, so they maintain the original scope no matter where exactly. So they maintain the original scope no matter where in the program their functions are eventually executed. This is called closure. This is interesting, and this is a static. This cannot be changed because it is determined at compile time, at parsing time. So the scope. So the scope, because now where you put the variables, where you as author put your variables, block, or function, this will be analyzed by a set of rule. This will be analyzed by a rule of scope that happened is at parse time. As a result, the scope structure is unaffected by runtime conditions. Jesus, French toast guy, bro. Is unaffected by runtime conditions. And because now functions are treated as value in JavaScript, pretty much like numbers and a string that you can assign or pass to. So since these variables, or since functions holds and access variables, they maintain the original scope. So exactly, they maintain the original scope no matter where in the program the functions are called. And this is called a closure. And this is what happened here about the closures. This is the true about the closure, and it is here with the abstract closure specification type, because it's the way of how now is an algorithm step together with collections of values are bundled together. Abstract closures. Holy moly. Okay. So things started to make a little bit more sense too. Okay. That'll be all for this video. Take care. Bye bye.